I am Krishnaveni, Assistant Professor, EC Department, KIT Kalaignar Karunanidhi Institute of Technology, Coimbatore. I am going to explain about image enhancement in digital image processing. First, we see about what is meant by image enhancement. It is the process that improves a digital image quality, detail and clarity to make it is more suitable for display or analysis by manipulating pixel values. Common techniques include adjusting brightness, contrast, reducing noise, sharpening edges and increasing colorfulness. What are the objectives of image enhancement? Visual appearance, clarity, noise reduction, highlight the features. There are two types in image enhancement techniques. First one is spatial domain method, second one is frequency domain methods. In spatial domain methods, we will directly modify the pixel values. In frequency domain method, we will transform the entire image by taking the Fourier transform. First, we see about the spatial domain filtering methods. In spatial domain, we have the three processing of operations: point operations, local operations, global operations. In point operation, we will change the each pixel's values. Normally, image is represented by the pixel elements or pixel values. Example, for 4x4 image, we have the 16 pixel values in row and column wise. We have total 16 pixel values. Each and every pixel values are modified using some of the transformations, that is called point operations. Local operations means each and every pixel values are modified by neighbor pixel values. Example, each pixel have the vertical, horizontal and diagonal nearby elements. The center pixel value is varied by surrounding pixel values, that is called the local operations. Global operations means we will change the each and every pixel values in the matrix by all the pixels in that image, that is called the global operations. First, we see about the point operations. Here f of x comma y is the input image, g of x comma y is the output image. So each pixels in the f of xy is varied by the sum of the transformation. It may be linear transformation or non-linear transformations, or logarithmic or inverse log or power law or nth root, etc. There are three basic transformations are linear, logarithmic and exponential. In this figure, we can see that identity and negative. So number of gray levels is varied from 0 to L minus 1. 0 is the black and L minus 1 is the pure white. In between we have the lot of gray levels. So in linear transformation we have identity function and negative function. So in logarithmic we have log and inverse log. Next, in power law transformation we do the nth root of the pixel. Similarly, we will do the nth power of the pixels. So changing the pixel value using this gray level information, that is called the point processing. It is one of the example for the image negatives. So black is changed as the white is changed as the black. We get the transformed output image as shown in the figure. It is one of the X-ray image. It has the black, white and gray, various gray levels. Show the output image. It has the black region of input is varied as the white region is varied as the black region, and other gray levels also changed as shown in the figure. It is one of the example for the gray level transformation. So it is the logarithmic transformation, taking the logarithmic of the pixel, some of the hidden parts of the image will be clearly identified in the output pixel as shown in the figure. Next we see the power law transformation. Depend s equal to c power some gamma value. Pixel value is nth power of some gamma value. So changing the power of the gamma value, pixel clarity or image clarity will be improved. So gamma is the one of the factor. It is varied from 1.8 to 2.5. So s equal to new pixel value equal to old pixel value c in c power some gamma value. Depending upon the gamma value, the image will be improved as shown in the figure. So original satellite image is captured by the camera. It is not cleared picture. So changing the pixels value using gamma transformation. So hidden parts will be identified clearly. So gamma value is 3, 4 and so on. So input image is not clear. Changing the gamma value, you take the C of gamma. C is the pixel value, gamma is the power value. Changing the gamma value, you get the cleared enhanced image as shown in the figure. It is called gamma transformation. Next we see about the global operation or histogram equalization is one of the global pre-processing technique in enhancement. First we see about what is mean by histogram. It shows the how many pixels in an image have specific intensity value. Example, how many pixels are pure black, how many pixels are dark gray, how many pixels are bright white. It is the number of pixel counts depends upon the intensity values. We can see 4 figures in this image. First one is the low contrast image. For low contrast image, the narrow width histogram shows a limited range of intensity values as shown in the figure. Second one is the dark image. So histogram indicated to left as shown in the figure. For bright image in the fourth one, the histogram is indicated in the right of this rectangular box. Last one is high contrast image. Yes, histogram spread evenly across the entire intensity of this rectangular as shown in the figure. So depending upon the histogram values, the contrast will be increased. Next we see about the histogram processing with example. So normally each and every image is represented by the matrix and pixel values. So example, in 4x4 matrix we have the 16 pixel values. These pixel values varied from 0 to 9 in that our example input matrix. So now we count the number of pixels in the each gray level. So in given matrix, example 5 is the highest gray level. So representing the gray level 5, we need the 3 bits. So number of representation of bits we needed, the number of gray levels is 9. 0 to 9 we are taking. Here number of 1s is 0, number of 0 is 0, number of 2 is 6, number of 3 is 5, number of 4 is 4, number of 5 is 1. This is the number of pixel values in the image. Next we find the running sum. Previous value is added with the present value. Consider previous value is 0, present pixel 0, 0 plus 0, 0. Consider gray level 2. Previous value is 0, present value is 6, 0 plus 6, 6. Again for gray level 3, previous value is 6, present number of pixel 5, 6 plus 5, 11. Gray level 4, number of pixel 4, previous value 11, 11 plus 4 15. Again in gray level 5, 15 plus 1 16 and 16 plus 0 and goes on. It is called the running sum. So this running sum is divided by the number of pixel values. You get the normalized values. So 0 by 16, again 0 by 16, 6 by 16, 11 by 16 and goes on. So running sum is divided by total number of pixels in the matrix. Again this value is multiplied by the number of maximum gray level. You get the new value, that is 0, 0, 3, 6, 8 and 9. So in input image 0 is replaced by 0 and gray level 1 is replaced by 0, gray level 2 is replaced by 3, 3 is replaced by 6, 4 is replaced by 8, 5 to 9th gray values are replaced by 9. So you get the new image. They are shown in the figure. It is the histogram output. So 0 is replaced by some value, 1 is replaced by some value. So you get the new image, that is the output gray image as shown in the figure. Now you draw the histogram graph. In x-axis we will take the gray level, y-axis number of pixels. That is called the histogram bar chart. So now you count the number of 3 is 1, 2, 3, 4, 5. 5. Number of 3 is 5. Similarly number of 6 is 1, 2, 3, 4, 5. So count the 8 and also 9. It is the histogram distribution of the graph. So changing the pixels values, the clarity of the image will be improved. It is called the global processing. Each and every pixel varied by the other pixels. It is called one of the image enhancement techniques used for improving contrast of the image.